Welcome to part 5 of this video summary. We'll be going through chapter 6, which covers through USART communication for the blue pill. This chapter uses message queues, which is a FreeRTOS API that facilitates inter-task communication. Message queues, as the name implies, is a buffer that could be used to hold a finite amount of data. They can be used to send data in between tasks and in between interrupts and tasks. They are also thread safe, which means that it will still work as expected even if it is used by multiple threads or function calls. This GIF, taken from freertos.org, perfectly sums up what a queue does. It uses the first in first out system, where the first data is written to the end of the queue, and that is the first data that is read by the reader. It is also possible to write to the front of a queue and to overwrite that data that is already at the front of the queue. Alright, moving on, let's take a brief look at USART. It's a popular communication protocol among hardware devices, which stands for Universal Synchronous or Asynchronous Receiver and Transmitter, which is unlike UART, which only communicates asynchronously. So, in UART mode, there is no need for a clock signal. Thus, one pin can be used as transmission and the other pin can be used for reception, where both reception and transmission can occur at the same time, which is known as duplex operation. Here's a sample UART data frame. The data frame is either 8 bits or 9 bits in length, where if it is 9 bits in length, that means that the parity bit is used as a simple error checking tool. It is either 0 or 1. It is 0 if the number of ones in the data frame is even, and it is 1 if the number of ones in the data frame is odd. Let's now take a closer look at a sample code that's given on the book. Before you do anything, you need to import the USART library and create a message queue for the UART message to be sent. The code has two tasks. Demo task, which sends the message. Now this is a message sent via RTOS into the message queue, which is then read by UART task and then sent to the serial output. Then we need to configure some settings, such as adjusting the GPIO pin into alternate function, setting the necessary parameters of our USART like baud rate, data size, parity, and stuff like that. And finally, create a message queue using the RTOS function xQCreate. So the xQCreate function basically creates a queue for the data to be transmitted. It takes into parameter, which is the length of the data, in this case it's 256, and the size of each data to be sent, which is 1 byte in this case, since it's the size of char. Now, just as a quick reminder, this is the overall structure of the code. We haven't touched any of this function yet, which is what I'm going to do next. The demo task function is pretty much straightforward. It is just a for loop that executes 2 UART puts function every 1000 milliseconds, which is every 1 second. And this attribute unused statement basically just tells the compiler that the pointer args variable is unused. This is to prevent compiler warnings. Now, let's look at the UART puts function, which is not from the libopencm3 library. Instead, it is a custom function that takes an array of characters and loop through every character and send them into the message queue through the xQSend function. This function takes in 3 parameters: the message queue handle, which is UART_TXQ that is created earlier, the data to be sent, in this case it is the array character, and finally the ticks to wait in the case that the message queue is full. Next, let's take a look at the second task, UART task. This task is just an if statement that checks for an input to the message queue. If an input is detected, it will send the character into the serial output using the USART send function. This function takes into parameters the USART port, which is USART1 in this case, and the data to be sent, which is CH, which stands for the character taken from the message queue. Meanwhile, the xQReceive function is the FreeRTOS function responsible for listening to new data in the message queue. It takes in 3 parameters: the message queue of interest, a pointer to a buffer for the message queue to be copied into, and the ticks to wait for the message. It returns PD pass, which is equivalent to true. Here's the overall view. A local character variable, ch, is created. It is then used to store the incoming data from xQReceive function, and finally, it is sent to the serial output through the USART send function. Here's an even bigger overview of the code itself, which we discussed earlier. Let's briefly walk through them. Inside the demo task, there's a function called UOutput, which sends the array of message using xQsend function to the message queue buffer. It is then read by the UOut task, which has the xQreceive function. And finally, the array is sent to the serial output using the USART send function. That was quite a bit of code that we went through. Now, let's do a brief demo of what the code can do. So I got my entire setup up and running here. So this thing is the USB hub connected to my computer, and this thing right over here is the ST-Link V2 programmer, and this is the FTDI to serial converter connected to the blue pill. Now, for the blue pill pin, there's this special pin here. Let me just take a zoom in. So this pin here that's connected to the serial converter is pin A9. Now this is a special pin that has been configured as the TX pin. And this TX pin will then naturally be connected to the RX pin to the serial converter. This way, the computer, or rather my computer, can receive message from the blue pill itself. Alright, so let's take a look. So let's try to build the project and flash it to the blue pill and take a look at the serial message output. Alright, so over here is the terminal itself, and I'm already on the project directory. So let's just run the make flash command here. Right, let me just run that. So as clear there's an error there, but don't worry about it. Just run the make flash command again. So alright, so when that's the second time, it will usually work, you know. So it's indicated by this thing right over here. So there's a couple of ways to check the serial output, but what I like to do is just usually open up my Arduino IDE, which I already has open here. Oh, I don't have it open, so let me just open my Arduino IDE here. Hang on, it's a bit hard to type with one hand, but alright, let me just open that up. Alright, let me just open that up, and you can just check the serial monitor for any serial input. Now, if you don't see anything on the serial monitor itself, it's fine. All you have to do is just press the reset button, which is what I'm gonna do here. So this thing is the reset button on the blue pill itself. Okay, press on it once. And now if you jump back to the Arduino serial monitor, you'll notice that it starts receiving message, which is good, which shows that everything is working. Alright, and another thing to take note that you need to set the baud rate at this specific value, which is defined on the code earlier itself. Alright, so I guess that's it for this demo. So that was quite a bit of stuff. Now I'm going to end off the video right over here. Thank you for listening. I hope you have learned something, and see you in the next video. Thank you and goodbye.